So homework was to, again, add some stuff to our parser, and then also add some stuff to our apply program, apply expression. How'd they go? Better? Not too bad? All right, so this guy should have been relatively easy. We did something pretty similar to it last time, so let's go ahead and throw it in there so we can build some more advanced Boolean expressions. So we're adding a and, or, and XOR or XOR, which I hate XOR, but whatever. All right, so we'll come up here to our parse expression. And again, we're dealing with things whose, we have a number, a symbol. Now we're dealing with things that are in a list, right? So after these first two, we can place these, the next cons. But we do need to make sure, actually, we have three of them here. So these three are literal values. If we think about it in our modern languages, these are literal. So just a number, a Boolean literal, or a variable name, right? After that, we can assume that what was given to us was a list. So we do need to make sure that we don't put any of these checks before this con because it is, or before these three, because it is related to, we're assuming that we have a list that we can take the car of. So EQV, car of EXP, if this guy is an OR, we'll go ahead and create a list. What we call this is just an OR expression. OR EXP. And then an OR expression has two expressions that come with it. So basically the same thing as this. Let's just write it. No, I don't want to write it. I'll steal that one and then I'll copy it twice. So we have an OR expression followed by that guy, followed by CADDR of that guy. All right, so that's for our OR expression. And then we can steal that whole thing for our and our XOR. I keep wanting to say XOR, which bothers me because I've always hated against XOR. All right, so this is an XOR expression. You missed a quiz? You didn't miss a quiz. No, but you didn't miss a quiz. You're okay. You can be relieved. XOR expression, blah, blah, blah. Okay, so that's that guy. I just said it. I said XOR, didn't I? It's just garbage. And then we have an and expression. All right, so you can see we're adding features to our language relatively simply through the parser, right? So we just keep expanding our language, and all this thing the parser does is get scarier and scarier and scarier. Now, at some point, we might decide that maybe we want to start modularizing our parser. So maybe we have a portion of our parser for processing Boolean operators, another portion for processing maybe Boolean expression-based things. So maybe we have a switch expression, we have an ifs expression, that kind of stuff. So just so we don't have this gigantic monolithic parser. All right. Now that would actually probably make more sense if we were writing our language, if we're writing our parser in a high-level language that was like more of a C-based language instead of scheme, which is functional. So if we were writing this in a procedural or an object-oriented language, especially an object-oriented language, by default we would be more modular and probably have a lot of this detail hidden behind objects. But one of the reasons we use scheme is because we can accomplish a lot of these things fairly concisely. Okay, so that should be the addition to our parser. Now we need to go down to our apply expression, and maybe we'll put these guys right above the other Boolean expression things in here. So we have our LT expression. So if EQV car parsed expression, if this guy is a OR EXP, if he's one of those dudes, then what are we going to return? We're going to return OR of apply expression with the E and V on this guy. So the catter, and then apply expression E and V on the CADDR. Like that. Similarly, let's do it for the and expression next. So this guy will be an and, that stuff. Now, is XOR built into Scheme? Good, 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 good. All right, so we actually have to write this then with the proper kind of conditional type thing. All right, so, oh man, how many of you did it with a let? No lets? So you called the same function twice? Disappointing. It's just terrible. All right, so for an XOR expression, we really want to get the value of these two guys. We don't want to have to call apply expression multiple times, right? So when we get the result of those two expressions, so we're going to throw those. I'm just going to steal this one line here. I've opened up a horrible can of worms of phone calls now. I was on one of those websites yesterday, and I was looking at, you click on one of those refinancing calculators just to look at what the current interest rates were. I kind of went through it, and now I'm on the list for, every bank in America calling you to try to refinance your house. It was off the hook. All right, what was I doing? Okay, so this is going to be for an XOR. So we're going to start off with a let, and we're going to go ahead and give ourselves the value of our two apply expressions for that. So we're going to have the body of the let, we're going to have exp1 is going to equal apply expression on the first part. exp2 will equal apply expression on the second part, CADDR. All right, so that's our local environment. We have our two expressions. All right, so now an XOR says that either one is true. Well, an XOR says exactly one of those guys is true, correct? And we have two things. So we need to ask, is the first one true and the second one's not true? Or is the second one true and the first one's not true? Make sense? So two ways for a XOR to be true. We can have the first one true and this other one false. We can have the second one, or we can have the second one true and the first one false. So we'll go ahead and return EQV exp1 true and EQV exp2 false. I'm going to actually kick this down the line just for organization purposes. Or exp1 is false and exp2 is true. Those are the only two ways that an XOR boils down to true. Otherwise, it'll be false. Make sense? So that means those of you who didn't use a let, you called apply expression 4 times?
I didn't do that.
How'd you do it?
I did not equal.
Not equal to what?
I just set it to not. Instead of saying XOR, I said not equal.
You said which was not equal?
Well, if they're not equal, it will come back.
Oh. So as long as not equal, say one of them has to be true in order for them to not be equal to each other, because two falses would boil down to false because it's not true. Two trues will boil down to false because it's not true. One true and one false. Yeah, that's a good one. That's better than mine. So what's up with you stupid people who use lets? Yeah, so what she did is, here, I'm just going to write it as a second predicate here just for example. So we'll call this a ZOR2. Oh my gosh, I did it again. All right, and so you dumped all this stuff. I'm just going to steal this one piece. And you said not EQV this dude. I'll kick this down a line. And that dude. Like that. That's a way better solution. How many of you did it that way? Just Annie. I want to point something out here. Remember last class? I was talking about the error checking and stuff like that. I said only Annie and I would be okay with these things, right? She proves us all right. Well, proves me right at least. But that's a good one. And when you look at it now, it seems obvious. That is a good one. But obviously, the reason I showed you the let one, it was good practice with lets. Go ahead.
Wait, so what that's doing is it's checking, so like if the first expression is true, it's checking to make sure that the other one is, so it's like saying like they both aren't true. Like,
well, it's saying they're both not the same. So, but yeah, you're right. So it's saying if this guy was true and this guy was false, it is true that they're not equal to each other. If this guy was false and this guy is true, it's true that they're not equal to each other. So far, we have those. That's what XOR is supposed to return. If this guy was true and this guy was true, which an OR would return true for, it's not true that these guys are not equal to each other. So this would return false. If this guy is false and this guy is false, it's not true that false is not equal to false. So, yeah, identical truth table. Yeah, that's actually a good way of putting it. Yeah, it happens to be an equivalent truth table, so it gives us the right answer. Yeah.
so the way I did it, was like I was using like the ands and ors, like I talked to Corey about it, and like, so like we did like and or and then not and.
Yeah, but you called apply expression multiple times for, you called it twice for the first one and twice for the second one.
I only called it twice, like I had the exact same thing, like the cat and the cat, but then like instead of the not equivalent, I had the and or not and.
So you have, what do you have here?
So I have the and then parenthesis or parenthesis, and then parenthesis not parenthesis and.
Yeah, I think if you're going to do it this way, there's no way you can get away without calling apply expression 2 times. So it was correct.
I called it 4 times.
He said it was correct. That's funny. You said it was correct.
You had the right combination
Of stuff, but just didn't call apply expression enough times. All right. So in any case, this is definitely, I think, the cleanest solution. Followed close, well, yeah, we'll say it's fair enough, by the let. The worst solutions, the worst correct solutions would have been the ones that called apply expression 4 times. Still correct. It's fine, but it's, we can appreciate the fact that if you're having to call the same functions with the same inputs multiple times, especially when this guy could be really scary looking, right? We don't know how flat that parsed expression is. You know, each call to apply expression might be another 30 calls to apply expression, depending on how complex that expression is. So effectively, when you called it an extra 2 times, you actually called it an extra 60 times in that example. Kind of get where I'm going with that. So that's where the let really can come in handy, because it says, I'm going to call this once, I'm going to call this once, I'm going to store the result. And then I'll go from there. All right. So that should be our, and let's, did everybody who wanted this let version have this written down? I'm about to dump it. We'll upgrade it with Andy's solution. Scream now. 3, 2, 1. Okay, so now we have ORs, ANDs, and XORs in our language. And we should be able to test that relatively quickly. So let's say that, well, here, let's just do an easy test of it. So we'll do AND, true, true. And that should give us a true, right? There's our true. And true false should give us a false. Or true false should give us a true. Or true true should give us a true. XOR true true should give us a false. XOR false false should give us a false. And then XOR true false should give us a true. Cool? All right. So really, only person in class who came up with that good solution was Annie. It's impressive. We get a star for the day. That's really good. That's not how I would have solved it. It seems obvious to me now, but I would have done it with the let. And I would have said, oh, well, that seems like the right answer, and it's good enough. So that's better than my solution. Which is obviously high praise coming from, perfection, right? Right. Okay, so now we have the ability to ask some more complex Boolean expressions. Still working mostly with numbers, right? We have a numeric-based base language. What else would be nice? So we kind of go down the list here. What's the requirements of a programming language? Requirements of the programming language is that we have the ability to remember stuff. So do we have the ability to remember stuff in our current language? Sort of through our let. So we have the ability to temporarily remember stuff. Could we actually, I think in our current thing, that's going to be the best way for us to remember stuff right now is through a let, because a let's kind of like either a class or a function call. We can think of it like that. We don't support functions yet, but that's not our next step. All right, so let's say we can remember stuff. Can we ask questions? Yeah, we can ask questions, and now we can ask pretty decent questions with our Booleans and stuff now. Now, maybe we can say our let's a little bit weak in that it only allows us to define one variable at a time. We'd have to nest lets inside of lets instead of lets. If we want 3 variables, we need a let instead of a let instead of a let. Maybe a little inconvenient. Not a deal breaker, but that might be something we want to revisit relatively soon. Okay? So we can ask questions. What are we missing? Repetition. Loops. So what's our favorite kind of loop? In most programming languages, what are the 3 loops we have available to us? For loop, while loop, Do while loop. What's the difference between those loops? What does a for loop lend itself to? Counting problems, counting types problems. What kind of problems does a while loop lend itself to? Well, they all have Booleans, right? Yeah, we don't know how many times we're going to repeat. So like, press any key to continue. How long is that going to be? Something like that. What about do while loop? Yeah, so do while loop is a type of loop called a post-check loop, where the other two are pre-check loops. So a do while loop is for problems where we need to do something at least one time. For instance, like authentication, right? So for loops and while loops both check the Boolean expression first before we ever execute the body of it even once. Do while loop executes the body of the loop once initially and then asks the question. Okay? Let's go with since we have a primarily number-based language at this point, for loop maybe makes reasonable sense for us. Like to just do something some number of times. Now, does it have to be a for loop? I mean, that's kind of our, almost our go-to move, right? But sometimes for a counting type problem, might it be better to just say do something some number of times, repeat 10 times? Right? I mean, that could be a thing. Because a for loop is kind of like that, isn't it? Now, what we're going to do is we're going to write the repeat. And then for homework, I'm going to give you the for. So repeat's easier to write than the for. But I don't want to really write the for today because it's just... We're going to have to see what Andy comes up with for the solution. That way we can all move forward next class, because we've obviously hit... it's all this pressure.
So the homework's only for her?
No. No. The homework's for everyone. We just expect the most correct answer from her. Right?
For third grade affects the rest of the class.
I told you the other day, you're one of my favorite students. True story. True story. Wish everybody worked. What's this?
I said she should be scared.
No. Nobody works as hard as Andy works. Every professor likes hardworking students. What was I talking about? Oh, repeat. All right, so we want to have the ability to repeat something some number of times. And what are we going to repeat? Some expression, right? So maybe our function looks something like repeat some number, so maybe 5, and then an expression. Okay, so and let's say, let's just use an example here. So we'll say repeat 5 times, we'll just actually just keep it relatively simple here. And we'll say an 8, just for no good reason other than, so this guy should ultimately display 8 5 times. That's what he should do, right? Now, what should this parse to, though? So this is probably going to be a repeat expression wrapped inside of the program, right? So this will be a repeat exp with a const expression 5, and then in this particular case, a const expression 8. So we're going to evaluate this expression. We can think of this as the body of the repeat. We're going to repeat that this number of times. Make sense? All right, so let's go ahead and let's add that to our parser. All right, and we'll go ahead and put it on top of these guys. So we'll say EQV car expression repeat. We'll create a list containing repeat exp along with, now let's go back down here and ask a question. Is this guy an expression? Can that be any expression, or must that be a number? That has to be a number, right? So realistically speaking, we probably don't want that guy to parse to that. We want it to just be that number. Does that make sense? Because it has to be that. Now, we could maybe make the argument that couldn't we say we want to repeat something a number of times, where a is a variable name? So if we're going to do that, then it actually does need to be an expression. It's just an expression whose type we assume to be a number. All right. So we can go either way here, right? We can say you have to give it a specific number, repeat something some number of times. Or we can make it repeat something an expression number of times with the assumption that an expression will be numeric. The second one probably gives us more flexibility, but also gives us the ability to introduce syntax errors that we're not checking for, but we already have that in our language. But do you understand the decision-making process here as the language designer that we're making? We're deciding, does it have to be a hard-coded number, or can it be a number or a variable name? Or if we invent something else that makes sense, which I don't know, I can come up with that right now, but would that work? So do we want to be able to use a variable name for our repeats? Probably makes sense. Okay, so with that in mind then, we'll leave this as a const expression 5. So we do need to call parse expression on that guy to get that expression. We'll just assume it's numeric. Okay? So coming back up here to our repeat, so we'll have repeat expression. Then we're going to call parse expression on the catter. That's going to be our number of times. And then we'll call parse expression on the rest of it. That's the body. So you could say, like, how many repeats? Body of the repeat. If you wanted to start commenting these things a little bit. Make sense? So that's our parser for that guy. Now, we'll come down and we want to add that ability into our apply. So let's do it after the, actually we can do it anywhere we want in here. Let's do it right before our ORs, right before our booleans. All right, so we'll say EQV car of parsed expression. If this guy is a repeat expression, then we're going to do something some number of times. All right, well, what are we going to do some number of times? Well, we're going to need the body some number of times. So what we're actually going to do here is, since I need those couple of pieces, might we do a let to grab the count and the body for our two expressions? All right, so let's start with that so we have our pieces. So we'll have a let, and our let will have count is equal to apply expression CADR parsed expression in our environment. And I'm going to just kick that. I don't know, did that gain us anything? I don't know if that gained us anything. And we're going to have the body is apply expression. Well, actually, let's think about this for a second. We are executing the body of this number of times, correct? So we actually don't want to execute the body yet, because might the environment change each time through the body? Potentially, right? We might have an updated environment. So that's it for our let variables up there. So we have our count, and now we want to do the apply expression of the CADDR parse expression in the environment. We want to do that some number of times. How many times? Count number of times. How are we going to pull that off? Do I need a helper function? I mean, I could build it internally here using a more powerful let. But up to this point, we've kind of relied on helper functions for kind of outsourcing this ability. So why don't we put in here a define repeat exp helper. And this guy will be a lambda that takes in a count, takes in a body. The body of it will already have the expression. So actually, maybe what we want to do is we want to take in the count, the body, and the environment. I think it's going to help us to separate those out. That way we potentially have updated environments each time through. Okay? We're going to have to think about how that updated environment will work. I mean, we might be fairly limited on what we can do with that right now. So we're going to pass this guy the count, the body, and the environment. And let's go ahead and call those pieces from down here. So inside of the body of this let, I'm going to call repeat exp helper like this. And I'm going to pass it the count. So there's my count. Then I need to pass it the body. So the body of this guy is going to be the CADDR of parsed expression. That's the actual expression. Make sense? It's not applied yet. It's the expression that we want to evaluate. It's going to be CADDR of parsed expression. And then the environment in which it's going to be repeated, at least the initial environment in which it's going to be repeated. All right, so that's what we're going to do with repeat exp. So it's going to come up here to this helper. Actually, did I call it repeat exp helper yet? Okay. All right, so now we're going to do something count number of times. How are we going to pull that off in Scheme? How do I do something count number of times? Forget about what the something is. How am I going to, let's say count was 5. How am I going to do something 5 times in here? Go ahead. Okay, so keep going as long as count is greater than 0. As soon as it's 0, that means we've counted down, right? So start at 5, so we'll do it once. 4, now we're at twice. 3, now we're at 3 times. 2, 4 times. 1, 5 times. Zip back through. Now we're actually at 0. We won't do it again. So we're going to keep going as long as it's greater than 0. We can say greater than or equal to 1. Something like that. All right. So we're going to do something that number of times. So we'll ask the question, if greater than count 0. If I'm supposed to do it again, do it again. And what am I going to do here? Well, I want to execute the body in terms of the current environment, correct? Now, that guy is going to give me a result printed to the screen or something like that. Now, is there a way for me to experience the changes in the environment? So we're seeing a limitation here. Before, when we applied our expression or applied our program, so really the core of our stuff is an apply expression, what did we do? We passed the changing environment in each time. But we had that environment as a local variable. Well, in this case, if I call, so let's just say in here, I'm going to go ahead and I'm going to call apply expression, passing it the body and passing it the current environment. When I do that, this guy will boil down to an answer. True, false, some number, whatever it is. He's going to boil down to a result. I won't have the updated environment, though. I won't have that guy. Make sense? How do I get it? Go ahead. You have an idea? Well, we can, but I already have E and B. I don't even need a let for it. The problem is that when this guy finishes, it's quite possible that this environment had changed, but I have no way of getting that environment back out.
So apply expression has to pass the environment back.
Well, you might hope that's what it does, but right now, what does apply expression do? It boils down to the result. So, it boils down to something like, a number, a 5, or the value of the variable b, which might be a 7, something like that. And that's just the answer. The environment gets used up. It's like, oh, I'm done. No leftovers, right? Not even paying attention to the fact that we might have to use that now potentially modified environment in a future thing. So as far as we know right now, the only way we can maybe pull this off is by somehow making that the new environment we live in, following this apply expression, exist in a global variable or something like that, right? But now we need to be careful because now we got to start thinking about scopes. Make sense how these things are going to start playing into it? Okay, so for right now, we're not going to support this with our repeat or our for loop. Okay, we're going to assume that it's the same environment each time and any changes are not going to have an impact. We want there to be changes related to an environmental change. That's important for us, right? So we might need to create a scope associated with our loops, a local scope for it. But we're not going to burn that bridge right now. So right now, the environment is whatever the original environment was, and that's going to be a limitation of our language. Okay? So we're going to apply this expression with the body we were given and the environment we were given this number of times. Now, I still need to be able to call repeat expression helper another time. Ruh-roh. What do I do with that? How do I call? So I really want to do these two things, right? I want to say repeat expression helper, passing it minus count 1, passing it the same body, passing it the same environment. I want to do both of these things when this is true. How do I pull that off? So now we're looking at a weakness of scheme. This is a functional language, right? If I want to see the result, this guy's going to boil down to some value, right? Couldn't I cons that value onto a list? So couldn't I do something like this? Cons whatever's returned by apply expression onto the result of repeat expression for the next time through. And that's what we do if the if was true. Else, boil down to the empty list to finish that cons. So our result will actually be a list of results. So if we do something 5 times, we'll have a list with 5 elements in it. The 5 results from our call. that make sense? So our result will be stored inside of that list. So if I want to do this repeat 5, 8 thing, just for no good reason, I should get 5 8s in a list, is the punchline there. So there's my 8s 5 times. All right, questions about that? So now let's look at what a for loop might look like. So for loops have the word for, okay? And we're going to do something as long as, now let's think about this. We're going to do something as long as some Boolean expression is true. So for some expression, repeat this body. Now, we're going to keep repeating this body as long as this expression is true. So, for example, I could do something like for a, well, we probably would do it like this, for less than a5. Maybe we'll just display, well, let's just keep it easy. We'll just boil down to a. But now, we have no way of a changing here, do we? So this guy would probably live inside of a let. So let a, actually, why don't we say, as long as a is greater than 0, we'll start a off at 5, like that. So let a equal 5, and then the body of this let will be this for loop. So while a is greater than 0, boil down to a. That's that. Closes that. That closes that. So now each time through here, a will still remain as 5. Is 5 greater than 0? Yes. 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 Infinite loop. How do we ever get a bigger than it was before? I need to have an increment and a decrement operator. And this guy should modify the current environment to change the value of a variable by 1. So if you want to do something like plus plus, that if you like that notation, you can do that, or you can say inc, whatever. So plus plus a would have a net result of a being 1 greater in value than it used to be in the environment. Make sense? And minus minus a would have the net result of a being 1 smaller than it was in the environment. We are not going to be able to do this for loop until we have increment and decrement. So for your homework, implement increment and decrement. Not the for loop yet. Make sense? All right. So I'll go ahead and put this up. I'll paste all the code. I will be putting up probably later on tonight or tomorrow morning the penalty assignment if you're not doing the hackathon. So be prepared for that. It will be equivalent to 12 hours of work, which is what the hackathon commitment was. All right, so big fun. All right, I will see everybody on Friday.